original talk was with CI/CD, but in the interest of time, I have to cut down a little bit. But we will still be covering about why CI/CD and what is the purpose of it. Right? So let's start with the necessary introductions. So that's my introduction, but before we start with that, huge round of applause to the DevOps Malayalam team for organizing such an event, and thank you all for joining. So as a candidate who has been out of Kerala, working outside Kerala for more than 15 years, I'm really happy to see that we have such a thriving DevOps community over here. Really glad to see it. Thanks again. So let us get into the intro, right? Now you know my name, and you know that I'm Kerala, and I of course speak Malayalam with some Malappuram accent. But for this talk, we are going to use English. Alright. So I'm Safir. I've been an SRE, DevOps platform engineer, and manager. I started off as a sysadmin. I don't know how many of you have heard that term, but I started like that in 2005. 18 plus years. I put plus because I don't want to really select how long it has been. And I'm an engineer, speaker, author, and I'm a continuous delivery foundation ambassador as well. We'll talk a little bit about that. If you want to connect with me, I'm on LinkedIn, Twitter, not very active, but still I'm there. That's my blog, Sree, and CDF Foundation Ambassadors. If you want to know about CDF Foundation, you can visit that. Alright, that's my book. That is about serverless solutions. Alright, moving on. Just a little bit about CDF, or the Continuous Delivery Foundation. So CDF is a foundation under Linux Foundation. I'm pretty sure you all know about CNCF. Similar to CNCF, CDF, OpenSSF, and there's a bunch of foundations like that. Alright, and CDF is very specific. It's a vendor-neutral body that hosts a number of projects in the CI/CD space. Alright, and their mission is to basically bring the vendors, the end users, and the open source communities, everybody together to set best practices, standards, things like that in the CI/CD space. And as ambassadors, it's our job to give publicity, work with communities, and make you aware of these kind of things. If you haven't heard about CDF so far, folks like me are doing a very bad job of it, but hopefully we can change that. If you haven't heard about CDF, at least one of these projects you would have seen. So these are the projects handled by CDF. There was a session earlier here today about Tecton. Jenkins, I'm pretty sure you have heard about. Jenkins is the new cloud-native way of running Jenkins. And there are a bunch of other products. So please check out cd.foundation. Okay, with that out of the way, the agenda for today, we will start with some basic introduction on APIs, API types, API specifications, REST APIs, etc. Then we will talk about why API testing, how we can test it, what is the use of mocks, etc. Then we will introduce the tool, the focus of this talk, which is Mockmo, and we will cover its UI, features, CLIs, etc. And at the end, we will have a demo. Alright, so starting off, this is a very boilerplate definition of APIs. It's taken mostly from Wikipedia, not my contribution, but the idea is to, the point here is that when we refer to APIs, we typically think about web APIs. But APIs started in 1970s or in that time frame, right? And the fundamental idea of API is it's a method or it's a way to connect to computing or software systems. That's about it, right? So that is how it started. Now, when we talk about web APIs, there are remote APIs using HTTP protocol, and mostly you will see this kind of Rust is something that you are all familiar with, but of course gRPC also, if you are in cloud ecosystem, you know about gRPC. Then there's GraphQL, WebSocket. So was one of the first APIs that I learned, and I still hate it. But Rust is much easier, and that is the focus of our project. So a word about API specifications, right? Some of you might be knowing about it if you don't know. So it basically if you are developing an API, it's a good thing to start with an API specification, right? And whatever kind of APIs you are planning to write, a specification will give you a way to express what you want to develop even before you start developing it. And that's a standard that you can use across, share with others, things like that, right? And as you can see, it provides standard language, and you can define request, response, what kind of endpoints, things like that, depending on what kind of specification you are using, all right? Now, there are various standards for API specifications. OpenAPI is one of the primary ones that we will talk about. Async API for asynchronous communication. There is SAML, WSDL, API blueprint, most of them for web APIs, right? And out of that, again, before we go into the specifications, just a recap on REST APIs. I'm pretty sure all of you know about this, right? For the context of this talk, we are mostly concentrating on REST APIs, and again, we all know that it's representational data. So basically, every resource, anything that you want to access from an API is a resource. It is represented in certain form, and the client actually, when it requests for a resource, the server transfers it. So that is trust, right? And resource is essentially the foundation of any REST API, which is the base information that it provides. Let's say you have library API, books are probably going to be one of your resources, right? So things like that. CRUD is create, read, update, and delete. So CRUD operations is essentially what you do over HTTP on any resources. That's what REST API gives you, right? So this is again the basic design principles of REST API. Right? It provides you a URI for accessing your resources. There is a standard for how your resources should be organized and made available. It's a client server architecture, and it is necessarily stateless, which means there is no relation between your one request and the other request. Probably except for authentication, but REST in itself doesn't want any state to be kept on the server side. Okay. Caching is something that REST recommends as wherever it's possible, and layered. It should be layered. Let's say if you the REST response client gets might not necessarily come from a direct server that you hit. It might probably come from a server that is behind it. It might go through a bunch of proxies like that. So that layered architecture is something that REST recommends. Now, coming back to OpenAPI initiative, this is the standard definition. Alright, the language agnostic interface to HTTP APIs. So the idea is that when you are using a specification, both humans and machines should be able to read it and process it. Alright, and typically when you have to understand an API, you actually have to go into the code, understand what kind of paths it or routes it defines, what is the handler for it, things like that, right? And what kind of input it takes, what kind of response it gives out. Now the idea with specification is that without any access to source code, the infra running this API, you look at the specification and you should be able to get a fair idea of what does the API do, what is the input it takes, what are the output it gives you, things like that. Alright, so this really helps. And some of the not everything is not exhaustive coverage, but some of the information that is in the OpenAPI specification. Ultimately, this is a JSON document. When you talk about a specification, it's like a JSON document, one or more JSON document. You will talk about what is the versions of the API, what is the description. Let's say if you have a API documentation outside of your API system, you can provide that link. It documents your endpoints, what xyz.com/abc, whatever is your endpoints, what kind of license is given for contact information for the server, things like that. Right? So these are the ways. These are the main things that is captured in an API specification, and most importantly, it documents every resource. Let's say you have an API for cats and dogs /cats/dogs. What are the requests that each of these takes? What are the responses it gives? The structure, everything will be defined. So that is the duty of OpenAPI. And why do we discuss this in a testing context? We will talk about that as well. Now let's come to APIs, right? API lifecycle. How does API start and end at this main end, right? Now, if you Google for API lifecycle, you will see a bunch of documentation for you will see 10 to 12 API lifecycle stages. Again, there is not one single standard here, but this represents the minimum lifecycle. Essentially, if you are creating an API, you are going to plan for it, you are going to design it, then you will develop it, test it, and once you are happy, you will deploy it, and then you will keep maintaining it. And maybe the cycle will repeat, right? You will develop further API endpoints, you will improve the existing API endpoint, things like that, right? So, in most of these places, you can use an API specification. Let's say you are planning for it, right? You are designing it. Right? At that point in time, the first thing you can think about is, okay, what is my API going to do? What are the endpoint it is going to provide? These are things that you can write in a standard language using OpenAPI specification. Right? And you write that. That kind of becomes your blueprint for for the software development, actual software development, right? Now there are libraries which can actually take an API specification and generate clients and servers for you. It may not be perfect in many cases, but it can do that. So that actually helps you in fast tracking your development. Testing is essentially about what? Let's say you have a REST API, right? When you write a test, essentially what you are going to do is, how do I hit a specific endpoint? What request I send? What is the expected response? And how do I evaluate it, right? And again, if you have a specification, your test framework can know that, okay, this is the kind of API that I'm going to talk to, and these are the endpoints, these are the expected request and response, things like that. And again, it can generate at least framework of test cases for you, right? So these are the usage of OpenAPI specification or any specifications for that matter, right? Now, when we talk about testing, right, this is a shorter version of what we call testing pyramid. Right, so testing pyramid, there are a bunch of different test scenarios, right? And the very basic and then the most common testing that we do in general is unit testing, and it's not different for APIs as well, right? APIs is also another software system. So you start with unit testing, where you will test your functions, classes, and things like that. In integration testing, you would move on to your all code is going to be tested in one entirety, and it will integrate with or it will work with the rest of the dependency systems, and that is what you do in integration testing. If you move on to end-to-end testing, you will essentially be testing multiple workflows, user stories, or user workflows, where you will have a bunch of APIs or a bunch of user interactions being tested. We are more concentrating on integration testing here. Right? Unit testing, of course, whatever software you write, you actually have to write unit testing and integration testing for sure. Right? And unit testing essentially doesn't change for whether it is an API or not. If the strategy is the same, you will have to write test for all your functions and your classes. Right? So our central theme again was mocks. Right? What do you use mocks for testing? So this is again standard definition. A mock object is an object that imitates a production object in limited ways. So you have an object. Let's say we are talking about in terms of unit testing. Right? You want to test a function, right? And you are making a call to an object or a class, right? It will give you some information back. It will take some input, return some output, right? The mock object basically allows you to imitate that. It won't do any internal processing, but it will accept whatever input you are giving, and it will return some outputs, right? So that's what a mock does. Especially in the unit test context, every programming language that you are using will have mock classes for testing. Right? So let's say I'm using Python. So there are Python mocks where I can just write or imitate inherit any class and imitate its behavior. Right? So that's what in unit test. That's how we use mock objects. But let us say we are moving on to integration test. Right? So this is more relevant because this is where we actually test our complete code with its full functionalities. Right? Now the challenge in integration testing is usually that your software is not working in isolation, especially if it's an API. You are going to have downstream other APIs, other systems that you have to talk to, right? Which means you need to have that entire system to be ready so that you can test your single API, right? Now, what is the good thing about having mocking? Right? When we talk about mocking in the terms of integration testing, it is not about objects anymore. It's about services or fake services that imitates your downstream dependencies. Let's say your API talks to another API, right? Now that API will have certain behavior. It will talk about it will have it will accept certain request and give some responses, right? Now if you are running the real API, your dependency API, first of all it's difficult to run your entire infrastructure to begin with. That API might have other dependencies, right? You cannot have handle everything. So rather, if you stand up or create a mock service, a mock API service as a dependency, then you can use that mock, which will behave exactly like your actual downstream dependency. Accept whatever HTTP request you send it and send back the response. Then that helps in faster testing. You have full control of your testing environment. You are not dependent on any other teams owning any other services. Okay. So it's a controlled environment. You can simulate edge cases. Maybe like you are dependent on your service A is dependent on service B, but the service B's author hasn't still written certain edge cases. It is still in development, or they haven't considered that. But if you have a mock, you can actually add additional features, additional endpoints, and test those edge cases, right? And it gives you complete test coverage because whatever feature you are providing, you can test all of them, right? Because you are not dependent on anybody else. You can write your own mock. And for continuous integration support, this essentially natural evolution to do it is basically to move it to your pipelines, CA pipelines, right? So unit test, of course, like you have frameworks which can automate unit test for you as long as you write or the proper test. But CI with the integration for other beyond unit test is a little tough, and that is where mock services comes into picture and helps you out. Okay, and we will see that in in a bit. Now we have been talking about mocks, mock services, right? What are they? Essentially, they are going to be tools where you can actually define one or more APIs, their endpoints, what is their responses for any request. That is what it does. And there are a whole bunch of tools. Some of the tools, it's not there are a number of tools. Mock server, Mockon, and WireMock are open source. They do have their cloud offering, but they are purely open source. Bceptor and Postman. How many of you have heard about Postman? Because most folks use Postman, yes, right? So Postman is again the tool is basically free for your developer, if you are a single developer. But beyond that, they have commercial offerings, right? Now the tool I have here is WireMock. It is again open source. They do have a small cloud offering, but whatever you can do it just WireMock and without any paying any money, right? So we will go into that. Mockon, right? Again, it's an open source, mocking tool. You can run mocks anywhere. It has a GUI, it has a CLI, so you can run it in desktop, C pipelines, GitHub Actions, containers, even serverless. It even has certain serverless libraries which you can use for AWS Lambda or Cloud Functions, anywhere, right? And this is the third one. I was already talking about import, export, mocks with OpenAPI. So let us say you are owning service API. And you are dependent on service B API. Then service B API, if it has an OpenAPI specification, you can actually pull that and import that OpenAPI specification to create your first definition of mocks. You don't have to worry about writing the whole thing from the beginning. It may not be full, it may not have be feature complete, but at least it will give you enough of a starting point, right? So that is one. Raw projects basically let us say you have multiple endpoints /cat/log. Probably you can use projects for matching different endpoints. Of course, CLI. And again, when you are testing, you need test data for a lot of use cases. You cannot code every single use case as or every test case with individual test data. So there are ways for where you can actually define array of data and use that, manipulate that, and return that as an API response. Templating again, this is written in Node and JavaScript, so you can use it in JavaScript language for templating the data and returning API responses. And you can return multiple responses for a route for an HTTP. Let's say /xyz.com/cat. You could have for different type of requests. You can return let's say 200 OK, but within 200 OK you could have different responses, or you could have 4 or 5 responses. Right? So that is the idea. There's a proxy mode where you can actually pass some part of your mock request to a different server, which could be your production server or your staging server. That's also possible. You can mock partial APIs and proxy the rest into a backend, different backend. It can also send files or store files and send it back. It can do latency simulation. Why latency simulation? Let's say you have a real world API, right? That API will take some time to you have a dependency, right? Let's say you have a dependency which will take some time to return data. Now when you write your mock locally, what happens is it returns immediately because it doesn't have to do anything. It just takes a response, looks at some configuration, returns you back the data, right? Now, if you have latency simulation, you can add, let's say, okay, return this result only after 100 milliseconds or 50 milliseconds to simulate a real world experience, right? So that is possible. So again, these are not full features, but you can the URL is given at the bottom, so you can go to mockon.com and check out the features. So this is just a quick walkthrough. We have a demo, but before that, I'm just giving a few stuff there, right? core concept of Gokulam is environments. An environment represents a single API. Alright. Let's say you have this service B which you are dependent on, your service A is dependent on. Service B becomes one environment. It will surround one code, and you can define as many number of routes and responses for them. Okay. And again, you can create responses, route response. Let's say /xyz. You can return 200. Okay. And then you can update the body to say okay, return this particular JSON value. Alright, and that's what the body thread does for you. You can even load data. There's which may be very visible body. There is inlet, which is what we are doing here. There is data that you can load from a data bucket, or you can even send back a file basically. Okay. So again, the root code, like I was talking about, for this endpoint, how much millisecond you should wait before sending the response back, things like that. Proxy I was talking about, if nothing matches, send the rest of the mock request to the proxy. Again, this is very quick view. So basically, again covering what these is required. Environment represents one API and it is some sort of unique port. You can create any number of APIs. There is no limits or anything. This is up to your open source project. You can export your API definitely as a JSON file, and that is what we will use for our CI/CD pipelines. You will see that. And you can have multiple responses per route. It can be based on certain routes. Different responses can be based on different routes. Or you can just have 10 responses for 200 okay, and then you can randomize and rotate it. So mock server will send you different responses every time. You can set a default response if nothing else works. You can have fallbacks to different routes defined within your API or to a different backend. Or you can also have certain callbacks. Let's say you hit a mock, your service here, hit the mock backend for service B. The service B's mock service can actually send a callback to some, let's say, monitoring system or logging system to say I want to hit by this service on this particular endpoint. So there are a lot of functionalities that you can extend and use. Again, mock on CLI. So we talked about GUI software, right? So ultimately, basically this mock on CLI is an NPM package. You can either directly install it or you can use it as a Docker container. Right? So this helps you in running this in CI environments. Right? For any sort of automation. And what you are seeing is the data file. I told you, right? Once you use the GUI and define your API and endpoints, you can export that as a JSON and provide it as an input to the CLI, so that the CLI will listen on that given port and give you that API. Okay. Alright, that's mostly about mock-on and mocking. Now we are going into the demo. So regarding the demo, so we are going to use some microservice architecture, and this is what we are going to test. Okay. So this is part of an e-commerce application, not a full e-commerce application, part of it. So what does it do? Let's say you search for something in Amazon or Flipkart, and you get a search result, right? And you click one of the products, then it takes you to the product page for the specific product. Alright. Now the product page UI, which we are not covering here, will send some details to product page API, which will send some data back, which is what the UI is going to show on the page. Okay. Now, in this case, what product page UI is going to send is the username of the cited user and a product ID for whatever product the user was clicking. Right? Now that product page API has to talk to multiple APIs to fetch this data. First thing it is going to do is talk to a catalog API, which will accept the product ID and return the product details. Second will be an address book API, which will return the which will accept the username of the signed in user, return the address or the current active address of the user. And again, I'm oversimplifying the whole thing for the sake of demo, but I'm sure you get the point. And both of these APIs are powered by MongoDB. The third one is serviceable API. So in the world of e-commerce, the term serviceable basically means, can a product be delivered to a certain customer at a certain location? Right? In some cases, when you search for certain products, you will see that this is not deliverable to your area, right? That comes from serviceability. Okay, so again, I have oversimplified this. It doesn't work this way in proper e-commerce services. But here, what we are doing is the serviceable API will take two arguments. One is a product. Second is the pin code of the default address of the user. And it will see, can this product be delivered to that pin code? How does it do? First, we will go to the inventory API, give the product ID, which is in the MySQL database, and look at which all warehouses has this product. Second, warehouse API will accept a pin code for that pin code will be the user's pin code, and it will look for what are the warehouses which can service this pin code. There could be multiple warehouses which can service this pin code. Now you mix and match both of those, you get whether the product can be delivered to that pin code. Okay, so again, very simplified, but that is the case. And this is our basic demo service. Okay. Few notes about this one. Again this sample code and everything will be published in GitHub. It is currently not updated. I will update it on Monday. There is some cleanup to be done. But this is done in such a way that you can run on your own laptop without any other additional dependencies. Have even avoided having to use Docker. This is a Python-based service. Uses called Flask-based microservices, Python Flask-based microservices. So it will be much easier for you to run this thing very easily, and you will see that. Okay. And there is some daemon service called supervisor. If you have used Python, you might have let's say just like handling system services or like any services. There's a daemon called supervisor which can handle running multiple services. So that's what I'm using for orchestrating all these services. So that makes it easy. Again, it is Python based. So the whole ecosystem is in Python, and all I need is a virtual environment in Python. Again, Docker installation of MySQL module, which you can do in your own laptops anytime. And Mocon CLI is installed as an NPM package. You can use it in a different way, no problems, but that is the easiest way, so I used it. And the repo, once it is updated, it will have all this code. So there are 6 microservice applications that you saw in the article. All of them are single file Flask applications, just with one route and one handler of function. Test I'm still actually properly writing it and modifying them. So, but there will be test with PyTest, at least for one of the services. And then there will be data scripts for the MongoDB and MySQL, simple scripts. And the Mocon data files, we will see the Mocon UI actually in the demo. And whatever you see in the demo, those files are exported, and those are the ones that are going to run as main services. And then the supervisor requires some configuration files that also will be there. So you will have everything that you need to run this demo on your laptop. Okay. So let's go to the demo. I think this presentation will be shared, and or you can take a photo of this one, but this will be available by Monday. Okay. So again, just to save time, I have recorded the entire demo. Let me see what is here. All right. Like 6 microservices backed by MongoDB and MySQL. Okay, so we are going back to the shell. This will be the repo that you will see once you close the application. So I'm going to run the supervisor here with the supervisor configuration. Alright, and this process you can run in the background. I'm running it in the foreground so that it's easier for me to kill that process. Ignore that error, that is not allowing for us. So now just to see that how so you will just quickly see supervisor even if you don't know, since you are going to run it, and you will probably modify this configuration files. Just a quick update how supervisor works. It has a configuration where you can define all the sub-processes you manage, and there is also a command called supervisor CDF which you can use for like looking at live. So quickly we will go through it. All of this is you guys adopt, so you will pretty much easily understand what I'm doing here. But I will give that information. Right, fast forward a little bit. So as you can see, these are the Flask applications that I'm running. There are 6 of them. Right, and you can see the configure ports as well where I was running. So supervisor here says that all of the services are running as expected because we started the supervisor in the background. So then another tab. Now I'm just checking where they're listening on the right ports. You can see that all these microservices are running on the ports expected from the configuration. Right? And what we are going to do is we are going to hit the product page API. Right? Because at the end of the day, that is the entry point for our entire infrastructure. And as long as product page API works, everything else will work because that is what gives you the entire information. Right? Alright. what you are going to see here is I hit it with like a user software and ID equal to 10. What you are seeing, so this is what will be returned to the UI. So what you are seeing is my address, pin code, the product is price and all, and serviceability is 30 years. So this is what the product page API produces and returns to the UI. Okay. Alright. So this is what we need to know, that the infra is only working fine. But I'm just for the command sake, I'm going through all the services and showing what it is doing. But I will go fast, given the interest of time. Access will returns my address, service will returns here, giving the service will look at and return the warehouse ID or the phone laptop. Warehouse service will return a couple of two warehouses. Out of 200 warehouse can serve my order, right? So now this is what happens in the production, right? Now you are running the product page service, the first service that we are seeing, right? And you have to do an integration test for that, for which you have to somewhere point. Again, just going back to the architecture, right? If you remember, product page API depends on all these APIs and all these systems. But when you are doing the mock, right? All you need to do is look at these three APIs. You don't. That is the beauty about mock, and you don't have to worry about the second order dependencies or anything beyond that. You just need to know what are your current dependencies or immediate dependencies and mock them. Okay. So this is how the mock will ultimately look at, right? You only need 3 mocks and your service running. Right? Now I'm going back to supervisor. I killed the existing supervisor. All the demons are down now, and I have an alternate service. So basically, what that supervisor dmCon does is it configures 3 mocons here, mocon services, and 1 product page service. And if you see, I am overriding all of the catalog URI, address book URI, and serviceable URI. Again, all these 3 are the direct dependency services. I am overriding all of them and running supervisor using a new configuration file. Okay, service is running. Again, we will. I'm just going to run through it. What these things represent. 1 fast application, 3 mocon applications. Alright, and these are the again I will go to the mocon UI at the end. But for now we will quickly see that these are the files explored. You can produce JSON files. Alright. So again, service are running, the port service running. You see here, all the respective mocks APIs are on 6% cities, and the original service is on 5% cities. Right. And let us, before we go to the product page, we will mock each of these mock services. I mean, just each of these mock services. So the mock service running on 6% for catalog is giving the expected result. Similarly, after service and service. Right. Now, next comes the product page service. So as you can see, product page service is the only access service that we are running, and we override the endpoints configurations for catalog, address book, and serviceability. And the mocon still I was able to give you the expected response, so that product page didn't know it was not talking to the original services. Right? So that is the whole idea of mock services, and how you can use them for testing. Right? Now, if you transfer all this configuration into your CA pipeline, which you can do with sidecars, or if you are using Kubernetes, or if you are using just VMs, you can even do it this way. Right? So as long as you have an orchestrator, you can run mock services with these mock files, and you can also run your original application on your own after you build it and test it. Right? Okay, we will quickly go to the second. Okay, so this is the mocon tool. Okay. Let me quickly go through this. Right. So first one, there are 3 on the left page. You can see there are 3 environments which represent 3 APIs. Right? And I have selected catalog API now. Catalog API has 1 endpoint, and that endpoint essentially defines what is the data to be returned. Right? So you can see response tree is 200, and it returns this JSON file. It's an inline array. But again you can add any method if you want to have a post-based endpoint, that's also possible. So and you can have multiple responses. I have 200 responses and 1 follow-up response. Right? And if you see here, there is something called rule. If you see here, what I'm saying is return that response only if code string ID is equal to 10. Right? Now this makes it easy for you to have different responses for different conditions. And there's no callback defined. There's a proxy defined. If nothing works, you proxy it back to some other service running You can modify the headers. You can add data buckets, and you can also log request and response, which will help you in troubleshooting how the communication is happening. Right? Again, we want another response, same thing. So we'll go fast through the address book. What's the same way? Okay, no difference. More difference is a case of serviceable because all of these are simple services, right? So everything has multiple response and configure. The only difference here is if you see here, there are two rules and there is an AND condition there. So you can combine multiple conditions here for your responses, either AND or OR. So that gives you more power to have complex conditions. So that's mostly about the video and the demo. Let's getting back to the slide for a few moments. Pretty much done. Alright, so just a guideline because we don't have time to actually show you this one pipeline. Typically, in the pipeline you would check out, you will optionally run code analysis for quality, and then we will do the test, and then you will build your application, right? And when you add an integration test to the your pipeline, typically you will have to whatever you generated as an application, whether it's a Docker container or some anything else, you actually have to deploy it as a because you have to do the integration testing of the entire system, right? So you have to deploy that, and then you have to deploy the mock service. And in most cases you will use sidecars or some process manager to run all these services, and then you will run a process with the test suite, which will hit this endpoint and do all the testing that we did right now in the demo. Okay. And if you remember, there was a Tecton session earlier. Tecton is a city foundation project for pipeline as code. So try it out. I wouldn't say it's very easy, but it's a fun thing to experiment with. So try it out. And that's about it. Thank you. I know I was all in the time. Sorry about it. Okay. Alright guys, thanks for listening. Any questions? I'll be around for an hour.